So we need to make sure that we're all on the same page with regard to the terms rotation and revolution. And I think already in my lectures recently I've talked about these two terms. The Earth rotates or spins, that's a synonym, completes one rotation on its axis now about every 24 hours. But actually historically, like back 4.6 billion years ago when it was just kind of a baby, our Earth actually completed one rotation much more quickly than that. So the Earth's rotation is slowing down, and that has to do with actually our satellite, the moon. We have a pretty darn big moon. Okay, other planets have moons, but ours is really pretty darn big. And actually the drag that the moon causes is causing us to, the pull that the moon causes is giving us a drag so that we're slowing down our rate of rotation. The other R, we need to make sure we're all on the same page, is that the Earth revolves or orbits the Sun. And it completes one revolution, the Earth completes one revolution about the Sun in about 365.25 days. And so we'll be talking more about this Earth-Sun system. But as we talk about it, let's see, do I have it? Oh yeah. As the Earth orbits or revolves about the Sun, that's when we get our seasons. Okay, so a little bit about the Earth-Sun system and especially this revolution. I already said that it takes about 365.25 days to complete one revolution. The Earth orbits the Sun in what we call a plane of the ecliptic. In order to define a plane, you only need 3 points. So pick 3 points in Earth's orbit about the Sun, and that plane that those 3 points that contain is the plane of the ecliptic. I should have gone ahead and shown you this. So pretty good diagram, says what we've been talking about. So the dotted line here is Earth orbiting the Sun, and the direction that Earth orbits or revolves about the Sun is counterclockwise if you're looking down at the North Pole. So looking down at the North Pole, it's like this, right? So the plane of the ecliptic then would be that light blue there. Let's see, what else do we need to know about the Earth-Sun system? Actually, we know that the shape of Earth's orbit about the Sun is not circular. It's in a shape we call an ellipse, which is basically a circle that's been kind of elongated. It's like an oval. And the Sun is located at a specific point in an ellipse called one of the ellipse's foci, which is just kind of off-center, a little bit off from the center of the oval. And so since the location of the Sun is a little bit off from the center of the oval, actually we end up in some point in Earth's orbit about the Sun, we are closer to the Sun, and at some point we're further away from the Sun. So we call those terms perihelion. Actually is when the Earth is closest. The Earth is closest to the Sun in its orbit. Okay? And here you can see the 147 million kilometers. And aphelion is over here, when the Sun is, when the Earth is farthest from the Sun, about 152 million kilometers. One of the things that you might kind of be catching your eye is that literally the distance between the Earth and the Sun at perihelion is when we're experiencing winter. And the distance at aphelion, when there's the most distance between the Earth and the Sun, is during our summer. So actually you can do the math, but this little bit of a difference, the 147 versus 152 million kilometers, that's not sufficient to really change significantly the amount of energy or radiation we get from the Sun. So the Earth rotates or or spins on its imaginary axis, an imaginary stick, okay? And as it spins, it creates our day and night. And the other thing I think we've been talking about, hopefully you're on board with, is that the Earth's axis of rotation that it spins on once every 24 hours is tilted. Whenever you go, and I don't have one here with me to show you, but whenever you go to buy a globe, its axis of rotation will always be tilted. And you might be saying tilted, you always see the angle as being 23.5 degrees. How tilted is the Earth's axis of rotation? And the way I best describe that is if you were to take the plane of the ecliptic and draw a line perpendicular like this, then go ahead and relative to the perpendicular tilt it 23.5 degrees, and that's what we're talking about. That's the tilted, that's Earth's tilted axis of rotation. Oh, and like this slide says, another important aspect about the direction where the Earth's tilted axis of rotation is pointing is it is pointing always to a distant star, and that star is, right now anyway, that star is Polaris. It's a star named Polaris, and sometimes we call Polaris the North Star, and that's because the Earth's north axis of rotation is pointed to Polaris. So if you can see this, I'm trying to show you, and I'll try to make sure the webcam captures this. If this is the sun, okay, watch Earth's tilted axis of rotation. Can you see I'm keeping the same tilt? Okay. So it took a year to do what I just showed you. This actually, so the tilted axis of rotation. More about the seasons then on a slide coming up.